See, Lindelof videos AP Calculus express, in this case, a definite integral in terms of u. This is our second video on this. Just before we get started, I do not intend to evaluate this definite integral, so I don't want to mislead anybody. But here we go. I'm going to do some u substitution here. And what's going to drive me to this u substitution is a couple of things. One, I don't know what to do with this mess here. I can't multiply this times this because we have a non-zero exponent here. And then I noticed something really weird. And what I noticed was that the derivative of this inside piece is almost perfectly this thing right here. As a matter of fact, it is perfectly the thing I'm writing in yellow, just not the negative sign. So I'm like, you know what? Maybe I can get something out of this. So this is what I'm going to do. I'm going to do a little u substitution, and I'm going to say, let u equal 4x cubed minus 1. And from here, I'm going to take the derivative of that thing I just created and say du dx is equal to 12x squared, right? What I'm looking for, frankly, is I'm looking for a replacement value. Well, let me show you where we are so far. Maybe this will help. So let me just write what we have done so far. I'm just going to rewrite this integral and say it's from 0 to 1 of negative 12x squared. But remember, I have this replacement value. U is equal to this. So where I found this 4x cubed minus 1, I'm going to put in u cubed dx. This is good and bad, and it bothers people a little bit. But here we have this integral in terms of u and in terms of x. That's not good. So that drives me to this. I'm going to take this derivative here, and what I would like to do is get a replacement value. What I'm looking to do is get a replacement value for dx. So I'm like, you know what? Let this dx be that one. So if I solve for dx, well, this is just algebra. Dx is equal to du over 12x squared. Hopefully you can see this. What's going to happen here? This 12x squared right here, is in the denominator. This one is in the numerator. I'm like, you know what? This is going to work out good for me. So I'm just going to keep using my replacement pieces. So I'm going to write it again. Definite integral 0 to negative 1, negative 12x squared u cubed. But now I have a replacement value for dx, and dx is this, is du over 12x squared. So maybe you can see this now, that this is the same as this, isn't it? So these two pieces cancel. The one thing I am going to need to do is I'm going to need to factor out this negative 1. I can just put it right there. I can just factor that out as a numeric value. And hopefully you can see this now, that I'm going to have this and this will cancel. So these x's are canceled. I have u cubed du. I should put this cube on the outside. Du. So I have this of u cubed du. This is in integratable form. I'm not going to do my integration yet. I'm not going to do my resubstitution. So if you're wondering, okay, Charlie, how come you're not doing the rest of that? Because that's not what this is. This is just talking about how do you express a definite integral in terms of u. So that's my response. So this is the second video. I hope it was helpful. If you have any questions or comments, please let me know. And if you haven't subscribed, please do. Thanks.